Well, just to set some ground, I will explain a little bit what is social metric. We are a SaaS company. We started in 2008. We do social media analytics, which is track the activity of your social properties like Facebook pages, Twitter accounts, everything that's social, and get information for brands and personality to make them understand what works and what they should do to do better. We are a multi-language, we're using a multi-language technology. We work in English, Portuguese, and Spanish. We are leader in Latin America, operating in 5 countries, including the US, with customers in the whole Latin America. And we are one of 34 companies that have this Twitter certified product. It's really hard to get one of those, and we are very proud to be part of this network. The kind of client, or the type of client that we have are Fortune 500 clients all over the region. And the kind of solution these clients buy, it's a dashboard. We can think as like a Google Analytics, but for brands, so you can understand what's going on with your brand, which type of content is engaging, from all your content that you publish, what content is really working on, and of course, all of this you can get from your competitors. So it's really great to understand that. You can also understand what time is better to tweet, to post something on Facebook, and get the best of information. Of course, who are the influencers of your account, gender, and demographic information. And also, it's very useful for clients that are using this kind of technology for understand the whole countries, like Coca-Cola or Pepsi. There are clients that use this to compare their activities on the whole countries and also with their competitors. We don't stay only on the quantitative side. We do a lot of qualitative information. So we have ontological models where you can understand what's a brand, what kind of product do you have, and topics of information. It's important because big brands try to push concepts, not only the brands. They try to, if you're just tracking like Pepsi, you're not tracking something meaningful. You have to track things that are related, like music, like healthy, and things like that. The marketeers understand this, and that's the kind of stuff they are really looking for. We do this through an ontological model. It's not a simple search, so we are doing this differently, and there are few companies in the world that are doing this approach. We can do with this kind of stuff. There are charts or reports just like that, which tells a brand what changed in a quarter for another quarter. So a company does a lot of effort with a new product launch. So the first quarter, the first ranking of the conversation is flavor. So the company is doing really, really well with the advertising. And then the next quarter, something changed, and they associate with breakfast. That's something really great for this kind of product, and that's the kind of information that we can provide. As well, we do real-time analytics, and this is the kind of dashboards that you can find. If you type this address, smx.io/reinvent, you can get the information real time. You can tweet right now and see yourself on our platform. Well, to set a little bit about the mood that we are going to talk today, I'd like to talk a little bit about the challenge that we are facing. The first challenge is variety. It's different data sources. Each data source has a different API. Each API means a different SLA. Sometimes the method is different, like pull for some APIs and push for others. And it imposes to us different rate limits and different bake-off strategies. It's really hard to face all this variety, and that's something that we have to cope day by day. Velocity, updates at every second. A tool like that I just show you, it's that have to update the dashboards each second, and it's something that we have to keep updating. Top users, top hashtags, we have to update each minute. And we do a lot of post-event analysis. So when something finished, we can do different analysis on the data set. And we have to cope with spikes of like 20,000 tweets per minute, which if you are doing Internet of Things doesn't seem much, but for Twitter, it's a lot because we do a lot of enhancement on those kind of information. And what does impose something like this? In the Brazilian elections, we are receiving like 25K tweets per hour, which is pretty good, but it's slow. And then during the last TV debate, there was this spike just in 1 hour. Everything concentrates on that, and we have to leverage on the AWS infrastructure to grow and to keep up with this ingestion and also processing. And after the winner have been announced, we have like almost 800,000 tweets. Another thing is disambiguation. Also, we are not just tracking common words. If you have something like oi in Portuguese means hi in English. So it's really hard to create meaning from the text. Or pan, which is in Spanish, is the same word for bread. In Mexico, it's a political party. And when we first run our tool, we had a lot of bread recipes on our system because it doesn't disambiguate at all. And of course, orange. I have for myself that the telecom industry hates us because all the telecoms in the world has names like this. We have orange, we have oi. In Brazil, we have something called vivo, which is like live, and it's very ambiguous, the information. Of course, we do a lot of data enrichment. So demographic information, sentiment information, influencers. And on sentiment information is not that accurate. We always have to do human analysis. And that's something that differentiates us as well from the competitors. We do all this stuff, and also it's really important to alert and report. One thing is we created a real clear, understandable UI, so someone that's non-BI expert can use our tool and can leverage and get real information. And also doing real-time alerts for anomalies. Now I'm gonna let you with Sebas, and he will tell you a little bit more about our evolution, how we are.
Hello. I'm Sebastian. I'm a solutions architect here at Social Metrics. As Gustavo told you before, we started as a small startup a few years ago, and we are growing a lot over the few years. And some of the challenges Gustavo just mentioned came with a really big challenge for us in the infrastructure team to evolve our old architecture to support new customers and always keep our costs down. So, of course, we have different drivers for the different evolutions that our architecture has different phases. Of course, we start growing and we have more customers. Not only more customers, but sometimes bigger customers. It's not the same to be monitoring a small media company in Argentina or monitoring Pepsi in whole Latin America. We added new features as every platform do. We started with some limited metrics and reports, and after a few years, we realized that we needed to expand our platforms and our products with new features and more data enrichment. And of course, we need to keep our costs under control. That's something that pretty much everybody here can relate to. As a startup, we need to keep all our monthly bill as low as possible. So, about our architecture evolution, I decided to divide this in 4 different stages, 4 different iterations. The first, it was the beginning of the company, as a startup, a small company with just a few customers, a really simple architecture. And after, you will see all the different iterations when we start changing, adding new features, new products, new customers. And one of the main things that I'm going to tell you about in this small story is how we started with a really simple architecture and all our framework explosions and different technologies we started to adapt, and how we are trying to keep that to the minimum to be more proficient in what we do. So for the first iteration, as I told you, we started really small, and what we needed at the time was a complete data isolation. We have a few customers, and for us, bringing them the best product possible was our main goal. So we needed complete data isolation, so pretty much if something goes wrong with one customer, the other ones just doesn't get noticed. And at the moment, we were trying a lot of different solutions and offerings because we weren't sure what was good for our solution. So what we did was a really simple all-in-one approach. I know pretty much everybody has been there. We started writing some code in Java and MySQL as a database, and each customer will get his own separate server with a MySQL database in it and our code running on it. And with this multi-instance architecture, of course, we had our data isolation that we wanted. But of course, the only way to scale this was vertical scalability. So if the customer is now having to ingest more data or monitoring more different sources, the only way to scale this was to bring a bigger box. And of course, we started doing a lot of MySQL performance tuning because bringing a bigger box is not always the best solution. Sometimes the cost can keep going up and up and up, and as a small enterprise, that's not good for us. Some of the things that we learned, multi-instance is harder to administrate, but it minimizes the stability issues that you can have as a small startup when not all the code is running as you wanted, and you're growing at the same time you're doing bug fixing and new features and stuff like that. So for that first iteration was something that really works for us. And vertical scalability, as you all know by now, is really poor resource management because the only way is to bring a bigger box, and with that your costs go up and it's even harder to administrate. And MySQL schema changes translate into downtime. Since we were using MySQL in a box for each different customer, every time we need to do some schema changes for new features or a different product, we need some downtime during the weekends or something like that. So then we moved to what we call our second iteration. At this moment, we started to take things more seriously, and we wanted to scale really big with new customers and new features and actually a new product. So we started rethinking our whole architecture, and we realized that we needed a separation of responsibilities. We needed to have different applications for crawling, processing, and data visualization in different servers so we can minimize the stability issues. We realized that horizontal scalability was going to be the future for us to have a really big cost reduction. And of course, since we were creating a lot of different servers for crawling, processing, and a lot of new different customers, we realized we needed fast provisioning. We couldn't be doing everything manual by the time. So what we changed it? First of all, we migrated to AWS. That was a really big milestone for us. With that, we started using a lot of different services that AWS provide and simplifies a lot of different managed services that we had at the time. We started using a message broker, in this case, RabbitMQ. That gave us the ability to minimize downtime for different schema changes or deployments on productions, since you can stop all of your crawling servers and having the processing and data visualization working with what has in the queue, and the other way around. We replaced MySQL with Amazon RDS. Since we're moving to AWS, it seemed logical to take advantage of all the different solutions and services Amazon provides. And Amazon RDS was a really good fit for us. And we started using AWS CloudFormation for fast provisioning of our servers, since we needed to do this migration live while still providing still providing our platform and products to our customers, we need to be really fast with this. And we started using auto-scaling groups as part of our whole architecture. So we can keep up with the different spikes, as Gustavo showed you before. We have, in social media, you can have spikes with different sources, depending on what's happening. And if you have to provide for the minimum and then scale up with auto-scaling groups, keep us cost really in the low. So some of the things we learned, provisioning our jobs, that's one of the really good reasons to switch to Amazon RDS. We were able to improve our performance, not only with MySQL and some fine-tuning in the parameter groups, but only the ability to keep adding provisioning jobs and have the ability to leverage on the provision performance that we have that we didn't have in the past with our own MySQL running on services. We started tuning out scaling policies, and we found out it can be really hard at first. You see all the small, short videos on the web that everything is just really fancy and works out of the box. But what we found out is that if you don't test your auto-scaling policies and you fine-tune that, you end up wasting a lot of money, because for a really small spike, you can end up spinning like 20 servers in just 1 minute. And maybe you just need to do that in a different pace. And AWS CloudFormation, great for migration, really allow us in the past to migrate our whole infrastructure in less than 1 month from different cloud vendor to AWS. But it's not enough for a daily operation team. It lacks some flexibility to do some of the things that we want to have really fast provision services. So this led us to a third iteration in our architecture. This was a really big milestone for us, because we ended up launching new products with a lot of different features. We started capturing a lot of bigger customers. So we need to deliver more complex analytics and metrics, near real-time solution for our customers. We need to scale fast. New customers were coming every day, and we needed to keep up with that. We need to be resilient against failure. We need to switch to high availability, so we have zero downtime, and the customer experience could be the best. And we were adding and improving data sources, as Gustavo told you before. We started monitoring just a few different social media, and we end up now capturing pretty much everything that is on the social media world. And that's a really big thing for us, because you start not only have to interact with different APIs, but also with the flow information keeps getting bigger and bigger with each customer. It's not only, oh, a new customer comes here, so now I have to monitor, I don't know, 1,000 fan pages from Facebook and 500 Twitter accounts for these customers. But you have to multiply that by orders of magnitude, because now you have to monitor Instagram and Foursquare and Tumblr and WordPress and stuff like that. And of course, we wanted to keep our costs under control. That's a big thing for pretty much any enterprise. So what did it change? Well, we started using different technologies that look, at the moment, seems the obvious solution for that, what we needed at the time. We started using Apache Storm for real-time processing. At the moment, it wasn't called Apache Storm, it was just Storm. That gave us the ability to do real-time processing of all the live Twitter feed for things like Gustavo showed you. We switch our message broker, our single node RabbitMQ in a small instance, to a bigger RabbitMQ with high availability. That gave us the ability to do upgrades and bug fixing and patches with zero downtime. And we started using Amazon EMR. We started doing some really cool metrics with the help of Hadoop and Hive. Since I told you CloudFormation wasn't good enough for our daily operations team, we started mixing things up with Chef. That gave us the ability to provision faster with more complex recipes to keep pretty much all the boxes up to date with the latest versions of our software. And that, so we didn't have to keep always updating the AMI that we use for CloudFormation. So it really allowed us to deploy a new customer on all his servers in just less than 5 minutes and 1 click. So it was a really big thing for our infrastructure team. And we started using Amazon S3 and his lifecycle policies to move data to Amazon Glacier to reduce our cost and to store all the raw data that we then needed to process with Hadoop and Hive. Some of the lessons learned for this third iteration for us, most of you might know about spot instances or reserved instances, but for us it was a really big deal to start buying reserved instances. With just a small upfront cost, you can really save a lot of money by the end of the month, and when you add up across the whole year, some people in your company are going to be really happy about it. You can use a spot instances for Amazon EMR and do some proof of concept with really just a few bucks and start spinning. Some of the not so good lessons that we learned. Hive is SQL, and SQL scripts are hard to test. So we end up sometimes with some bugs in our Hive scripts that the data was not going to be processed okay, and we end up learning that after the whole processing pipeline has ended. And regarding that, bulk upsert on RDS can be expensive. If you are doing bulk upsert from Hive to Amazon RDS, you need a lot of PI ops to be able to have good performance with that and do it in a really small amount of time. And that can be quite expensive instead of just having a small flow of information doing upsert. We tried Amazon DynamoDB in the past. It's really great. Our whole developer teams love it, but it was really expensive for us because you are paying for the maximum amount of write requests or read requests. And for us at the moment, as I told you before, we were batch processing a lot of information every hour, and that gave us a limit. So you have to provision a really high write request capacity, and that was really expensive for us, even though we were only using it just 5 or 10 minutes every hour. So this is a small diagram of what we are doing right now. As I told you before, after the third iteration, we start separating everything, and we have our crawling servers in one side, our message broker as a queue, and we're doing something like Lambda architecture right now. We're doing stream processing on one side, and we're saving all our raw data on S3 at the same time we're crawling it to do batch processing later. Because sometimes you need to answer different kind of questions in social media analytics. Like, it's not the same if you need to have metrics about what's happening right now, like the amount of tweets that you guys are doing about reinvent. You need to do real-time stream processing with that. But sometimes you need to know just about the top hashtags that were used or the top users that were writing about that. And the best things to do that, or something like average response time of the guys are here at reinvent or something like that is with batch processing. So right now we're doing both, and we're having everything stored in a database, and then we have a data visualization. So then it comes the fourth iteration. This is what really gets me. We needed to monitor millions of social media profiles. The company got bigger, new customers, bigger customers, new products, more social media that we need to monitor. So we need to scale up really big. We need to make the data accessible. In the past, we were storing raw data, but we weren't really using it because it was so much data and we weren't storing it properly. So it was really hard for our developers or data scientists to do something with that. So we were processing it and showing nice reports and analytics, but if you wanted to do something with the old data, it was really hard. So we needed to do accessible our data for exploration, proof of concept, and a lot of different stuff. We needed to improve our UI response times. When your database gets too big, your response times start slowing down, and we couldn't keep at just adding PI ops, and that's it. We wanted to improve that. And we realized that we needed to do testing in our data pipelines. We couldn't wait to learn that something was wrong after the whole data processing pipeline. Of course, since we wanted to make our data accessible, we needed to be able to reprocess, and of course, reprocess faster. Sometimes you have some downtime, or sometimes you get different customers asking you about what happened the last year. So we need to start reprocessing a lot of different old data that we have stored in the past as raw data to give metrics about what happened in the past to new customers. So some of the things we changed for this last iteration. We switched to Cassandra, actually to DataStax. That gave us a really low response time for our UI, really high availability with our whole cluster. We're now running different instances in different availability zones. So we already tried this, but when you start killing instances or they drop for some reasons, everything just keeps running. We even the past week, actually, we were doing some load testing on our new API that was hitting against Cassandra. And while we were doing the stress test, I started doing an upgrade on DataStax. If some of you use DataStax, an upgrade of the whole version do a rolling restart. So that means that while we were doing a stress test on our database, I was rebooting the database, pretty much all instances. Nothing happened. The stress test was amazing, good numbers, everybody was happy. So as you can see, with Cassandra, we end up having a better uptime, better response times, and we can sleep okay in the night. We started using MongoDB, not only MongoDB, but MongoDB MMS. We switched our whole configuration database to MongoDB. We're still storing the processed data for the dashboards in Cassandra, but the whole configuration of the different applications and microservices are storing in MongoDB. And with MongoDB MMS, if you haven't been, yesterday there was a really good talk about NoSQL and EC2. But with this new version, 2.6x, you can do some really cool things with automation. It really integrates with AWS, and you can spin up a 10-shard replica set on different availability zones with just 3 clicks and no hassle. Really good. And we switched to Apache Spark. We ditched most of what we were doing with Hive, and we switched to Apache Spark that gave us the ability to do real-time and batch processing without rewriting our code. And also, since we're writing in Scala, it gave us the ability to do unit tests for our whole data processing pipeline. Some of the things that we learned with this last iteration for us was to leverage the whole AWS ecosystem. Not only the whole AWS services, but the whole ecosystems. Sometimes some of the services Amazon provides is not enough for what you're doing, or sometimes it's not a really good fit for what you need. But there's a whole ecosystem out there that works with AWS and integrates really, really good. As an example, we weren't going to use DynamoDB because it was quite expensive for our use case, but Cassandra was just what we needed. Thanks for that big ecosystem integration, Data stacks have an AMI that you can just spin up your own data stack cluster with different instances in different availability zone or region with just a few clicks through a really nice web interface. As I will tell you, with MongoDB MMS, you have the whole automation agent, backup agent, and monitoring agent. So you can configure your whole replica set cluster in just a few clicks without any hassle. And with Apache Spark, since we were not using Apache Spark on EMR because the version of Spark on EMR was old and we needed the latest version, we run our own cluster on EC2. But thanks to the integration Spark already has with EC2 launch scripts, you can set up your own cluster in just one command line, and that's it. As I told you before, in this case, EMR sometimes don't have the latest stable versions because it takes a lot of different testing and to get that to production. But you can really leverage off what people are doing and integrating with AWS and the whole partner network. So this is some more what it looks like right now. As you see, we're doing auto-scaling group for different processing, stream processing and natural language processing. We have our MongoDB database for configuration management of all our different instances. We have our own RabbitMQ high availability cluster for message broker. And we're storing all the raw data in S3 with lifecycle policies, of course. And we're doing stream processing and batch processing with Amazon EMR and Apache Spark. And we save that to Cassandra. All of that, we have a really cool data visualization team that is working with some really cool dashboards and consumes that information from the different database depending on the different platform that we're using. It can be Redis for our stream processing engine. It can be MySQL for our natural language processing, or Cassandra for our batch processing. So some of the things that I told you as I was telling you about different iterations was keep the cost down. So this is a really cool chart when I can show you how our active customers were growing over the past 4 years and how our cost went up and then went down again. As you can see, the big spike and then goes down like 60%. That's when we moved to AWS. As you see, when we start doing a lot of different testing with different frameworks and technologies, of course our cost keeps going up, but also our revenue. So that's logic that happens, and our customers keeps going up. So we stay down and our margins are better. So I'm going to leave you with Gustavo right now so he can tell you a little bit about some of the lessons that we learned with this whole journey that we took with our evolution of our architecture. Thank you so much.
Well, one thing that I like the most is try to share the lesson learned. I always love to go to sessions and see what people made and what kind of mistake they made, so I try to create a different path. I hope our path and our mistakes help you as well. The first lesson learned is automate since day one. We always start the same. We go to the web browser, we launch a few instances, and we start our company. And then you turn around and come back, and there are 5th instance. And it's really hard to start to automate once you are growing so fast. So it's important to try to do this from the day one. It's a hassle for the developer, the develop team. Sometimes they say, oh no, I can do faster if I do it manually, then we go to see it later, but later is always a problem. Monitor your system activity, understand your data pattern. Because the data is so huge and it changes all days because it's human behavior, you can't get the specific numbers. It's difficult to set a threshold like we used to do in memory or processor. I can do something like alert me if we reach 6% of CPU usage. We have to understand the data patterns and understand how the data should look like. It's really hard to set automatic alerts. We are doing Logstash, but we see a lot of companies here and partners, Amazon partners, that do the same kind of stuff. Always, always, always have a source of truth. If you can just get out here with one thing, is source of truth. One thing that I learned from the big data book from Nathan Mars was this one. This kind of thing was since it was written for us, because we lost data on the beginning because of human mistakes and software mistakes. So everything that comes through Sociometric, the first iteration, the first thing that happens is goes to S3. Then after that, we start to look around and play with data. But we always have the data secure. And also, using Glacier, you can have your retention policy, and you can save money as well. And as Seba mentioned, make your software truth searchable. It's really difficult if you have a lot of data, but if anyone, if you're a data scientist, if someone asks for you, do you have this kind of information, or can I do this thing? And you don't have this information, it's not easily searchable, it's difficult. So we are doing this with Elasticsearch, and it's going well so far. If you are doing analytics, approximation, it's a good thing. I mean, if you're trying to count things exactly, you are doing wrong. I'm sorry, but you are doing wrong. Check hyperlog log, count min sketch, and Bloom filters. Those things we're gonna save a lot of memory, a lot of time, and a lot of head check. I mean, things like hyperlog log can count for 1 billion with 4K of memory, 4 kilobytes of memory. Try to count 1 billion with a hash set and tell me how much memory you're gonna use. Write your own pipelines considering reprocessing. Sometimes we create the pipelines to be optimistic. So if data arrives in the order, if data arrives correctly, then we process and everyone gonna be happy. But what happened in the real world is that sometimes one crawler crashes, or the API has a rate limit, or sometimes Facebook does something crazy and we don't have API access. It happens. So you have to figure out how to create your pipeline, considering that you have to reprocess information. And as you see, avoid at all costs the framework explosion. It's a trick lesson learned, because we have to do all this path through to understand what works for us. But on the other hand, when an engineer come to work in social metrics, it's really hard to him or she or her to understand all the patterns and everything that they need to understand. I was set up in another day, I had to set up an old project, and I spent like 2 days with things like, okay, it depends on Mongo, Redis, Storm, MySQL, a lot of stuff. It's not fun to do this kind of stuff when you try to iterate faster. And we love Amazon because of the ecosystem, not just because the system they have, but because we have an ecosystem that we can rely on. And what we think that's gonna be 2015 for us. Bless you.
Thanks.
Well, you see this, and that's our architecture evolution, and that's our framework explosion. And it's becoming unmanageable, all this stuff. It's really fun. I mean, working social metrics is really fun because you can try a lot of different things. But from the perspective of being productive, sometimes these things are it's against you, works against you. So we are trying to reduce some moving parts, have the less frameworks as possible, and even if they are not the exactly good fit, I prefer to take out something and have something that's not that good, but we are already using. For this, we are using Apache Spark. We understand that's really cool for micro-batch processing real time, because we are not using really real time to microsecond. We can rely on second, so we can use micro-batching, and that Spark is awesome. Batch processing as well. And one thing that I'm really fan of Spark, that's the same pipeline that you create for a batch processing, you can reuse it for stream processing. So it's really wonderful. Kafka, or Kinesis, for message broking. It was kind of funny. It was an edit on my slide, because I was convinced that Kafka before I come here, and after attending to a few sessions, seems that Kinesis, it's a good choice for us. Cassandra to time series, and Elasticsearch for content indexing. That's what we think that we're gonna be in 2015. So we are here, and we believe to go to the infinite and beyond, we have to reduce our stack. So that's one thing that we are really working hard right now, is how to reduce this to make it more easier, to make it scalable, and if someone new come to social metrics, they don't have to learn 300 different frameworks. So that's what we have to tell you today. I would like to say that it was architecture 202, so we didn't go deep in any of this technology, but we are here, and we would love to talk to you guys on the hallway and learn from your systems and try to work together. Thank you.